Hello class and welcome back to Algebra 1B Bootcamp. Today we are studying frequency and tables and probabilities. And the easiest way to do a frequency table is really just to plug in some numbers and see how it works. A frequency table is just a way of organizing the information that you have. A lot of times when you're doing data, you have a lot of different numbers and a lot of different things. And if you can organize them in a table in some way, it makes it easier to make conclusions. So let's look. A survey is conducted among school students. 50 students are randomly selected, and they are asked whether they prefer dogs, cats, or other pets. In the survey, 10 boys preferred dogs. Let's put my highlighter here. 10 boys preferred dogs. 9 boys preferred cats. 3 boys preferred other pets. And then we have some girls. 12 girls preferred dogs. 6 girls preferred cats. And 10 girls preferred other pets. And we're going to construct a two-way frequency table. So if you notice, I've already got it filled out. We have boy, girl on this side, and then cat, dog, cat, and other on the other side. So we're going to fill in what we know and then calculate totals. So let's start. A girl who likes dogs. There are 12 girls who likes dogs. So 12 goes here. Then a girl who likes cats. There are 6 girls that like cats. And then the other category, that's the 10. Now let's look at the boys. The number of boys who like dogs would be 10. The number of boys who like cats is 9. And then the number of boys who like other pets is 3. So after you do this, then the next step is to calculate all your different totals. Now, you just need to be careful when you're calculating your totals that you calculate correctly. So all you have to do is just add across the column. So I'm going to do 12 plus 6 plus 10. And that makes 28. So in this study, there are 28 total girls. Go this way across this row. You have 10 plus 9 plus 2, which is 22. So in this study, there are 22 total boys. And that takes care of those columns. Now, let's go, or sorry, those rows. Now let's go down the column. So the number of people who like dogs would be 22 plus 10, or sorry, 12 plus 10, which is 22. Now let's figure out the cats. You have 6 plus 9, which is 15. And then the others would be 13. Now, this is always a way to check yourself, because this box, when you add down this column and across this row, this box should be the same for both totals. So 28 plus 22 is 50, and then 22 plus 15 plus 13 is conveniently also 50. So if you notice, the number 50, that's the total number of people in the whole survey. It even tells us that in the beginning. There are 50 students who are randomly chosen. Now, once we have our whole frequency table filled out, we can answer a bunch of questions about the frequency table. Let's see if I can get as many of these in here as possible. All right. So, how many total people are in the survey? 50 people. How many of these people liked cats? Well, read down your cat column. That would be 15 people like cats. How many girls were in the survey? Read across the girl row, and that's 28. What is the probability that anyone in the survey likes cats? So, keyword anyone. So you're looking at your total number of people, which is 50. Remember, probability is like your number over your total. So the number of times it occurs over the total number of things. So in this case, we have 50 people. The probability that anyone in the survey likes cats. Let's go up to my cat column here. 15 people like cats out of the whole 50. So 15 out of 50. We can reduce that. They're both divisible by 5, so it would be 3 out of 10. Whenever you're talking probability, you always want to reduce your fraction. What is the probability that a boy in the survey likes another type of pet? So this is reducing what we want. We want the number of boys. So the probability that a boy in the survey, so there are 22 total boys, prefers another pet. So you're really only looking at the boy column. There are 3 boys out of the 22 who like other pets. So 3 out of 22. What is the probability that someone who likes dogs is a girl? So that tells us the person who likes dogs, so we're looking in this column right here, the probability that someone who likes dogs, so 22 total, is a girl would be 12 out of 22. Those both divide by 2, so it would be 6 out of 11. So now let's look, what is the probability that a girl prefers another pet? So now we're looking at the girls. Girls, there are 28 total girls who like another pet. So we would do 10. 10 out of 28, those both divide by 2, so 15 out of 14. Okay, just a few more. What is the probability that someone in the survey likes cats and is a girl? So the key thing here is it's someone in the survey. So that's out of the total number of people, which is 50, who likes cats and is a girl. So we're getting really specific on the column that we want. So out of the whole survey, the 50 people, what is the probability that a person, if you grab a random person, that person is a girl and also likes cats? So you're really only looking here. 6. There's one box that fits that column, fits that category, is a girl and likes cats out of the 50. So you would say 6 out of 50. 6 out of 50, which is 3 out of 25. And then what is the probability that someone in the survey, so that's the total, likes cats or dogs? So that's getting a little interesting. Let's scroll back up. So the probability that someone in the survey, so out of the whole 50, likes cats or they like dogs. So they could pick one or the other. It doesn't give us any condition about boy or girl. So someone in the survey who likes cats or likes dogs could be any of those people. So 12 plus 10 plus 6 plus 9. So there are 37 people. You could add up all 4 of those boxes, or you could just add those 2. So 37 people out of the whole 50 like cats or dogs. All right, show me your notes when you're finished, and I'll give you your assignment.